Hello all you Murgetroid maniacs. Today I'd like to give you an update on the Murgetroid. I think the last update I gave you was back in Easter. I mentioned at that time I needed to add an on-off switch to the Murgetroid, which I have now done. This has turned out to be an extremely difficult problem, which we'll talk about in this video. But before I do that, I want to show you what I've done since Easter. I want to show you a new graphical user interface I developed for the control of the base of the Murgetroid. But before I do that, I want to first show you that the Murgetroid does in fact start up. So let me show you how it starts up, and then I'm going to show you the graphical user interface. So now I'm going to turn on the Murgetroid with the on-off switch, and you'll see that it starts to spin up very slowly at first and then builds speed. You'll soon see that it'll throttle back a little bit. Maybe you won't see that, but it started up nicely. It gets up to the speed of about 300 RPM and continues from there. So at this point, let me show you how the graphical user interface works. This is the new graphical user interface I developed for control of the base of the Murgetroid, and it allows me to monitor various possible fault conditions of the Murgetroid, including things like excessive vibration, motor temperature being too hot, revolutions per minute of the Murgetroid being too slow or too fast, or if the 12-volt supply to the rotating head of the Murgetroid is too high or too low. You can see it's connected via Bluetooth because it's flashing. I've got other features I can do. I can turn on and off the Murgetroid, which I'll do in a minute. It shows that right now the Murgetroid's not spinning because the motor is disabled. I can disable the motor if I choose at any time. I can clear a fault and have it spin up by using these buttons here. And these allow me to monitor the various aspects of the Murgetroid. Over here, I've got my motor speed control. It's in 4 bits. This is the least significant bit. That's the most significant bit. Each bit is a factor of 2 different than the others. So this is 1, 2, 4, 8 for a total of 16 positions, including 0. These positions allow me to center the motor speed around 330 RPM. So right now I'm going to spin up the Murgetroid, and what you'll see happen, I just turned the Murgetroid, and the motor speed is going to start by going to high speed, and you can see it's ramped itself up, and then it's moving now, spinning quite fast, and it slowed itself down to lower motor speed. You can see the RPMs changing. It should settle out to around 330 RPM. What I do to adjust it is I basically turn that on to calibrate, which forces these 2 bits to be on, and then I tune the motor speed control, which is the knob on the Murgetroid, to get me the 330 RPM, and then I turn it off the calibration. I can enable or disable the faults. And that is what I have here for the GUI. You can see once here the motor is right 79, 80 degrees. The voltage is about 11.7. So this is all very useful and good. Let me show you what happens if I create a fault. I'm going to turn off the motor. Right now I just turned off the motor, not the Murgetroid, and you can see the RPMs are dropping. Motor speed controller increments to try and bring the speed back up. Eventually it'll fail, and presumably that RPM too slow light will kick in here in a second, and the motor will be disabled. So it should happen right about now. There it goes. So RPM too slow, motor disabled. That's the new GUI. This is the underside of the new base. Here's the famed on-off switch coming through there, and it turns on and off the power to this power strip, which supplies power to the system. It also provides 5 volts here on this USB output. These are the control boxes. This is the base control with the microprocessor in here, and wire connects to the computer, which allows me to program it. I don't need this wire in all the time, only when I program it. Rest of the time I connect to this microprocessor through Bluetooth. In here I've got a bunch of relays that are isolated from the microprocessor due to noise issues, which are talked about in this video as well. We've got the main motor, of course, with the fans to keep it cool. 12-volt power supply. This is the new motor speed controller that I speak of in this video, as well as an on-off for the motor itself, not the whole system, just the motor to allow me to shut off the spin. So that's the entirety of the system. Okay, so now I'm going to explain some of the difficulties I had in getting this thing to operate correctly. So as you mentioned earlier, the Murgetroid likes to spin at about 300 RPM or so, and the motor itself actually wants to spin at about 1500 RPM if you just plug it into the straight AC 120 volt source, which means that I need a motor speed controller in order to adjust the speed of the motor down to 300 RPM. And had been using this motor speed controller, which is a fan speed controller I got off of Amazon. And you'll see it plugs in to the AC just like anything else. And at the output here is where you would plug in your fan, or in my case, the Murgetroid motor. And there's a knob on top that allows you to control the voltage at this output and adjust the speed of the motor. There's also some switching here that allows you to go from this variable speed to full speed or to off completely. And this was exactly what I needed at the time, and so I was trying to use it in order to control the speed of the motor and also start up the Murgetroid. Well, it turns out because the Murgetroid is now completely covered in this HEX dome, that there's virtually no wind resistance that the spinning head it comes into contact with, which means that if I have the motor speed adjusted to 300 RPM and I turn off the Murgetroid and turn it on again, there's not enough energy, as it turns out, to get it spinning to go back to full 300 RPM. So it just sits there and kind of hums and doesn't start spinning. I needed to boost the speed temporarily in order to get the Murgetroid started. And it turns out there's quite a number of different ways you can do that, and I think I've explored all of them at this point. And I'll tell you the path that I took initially. So what I decided to do initially was to bypass the output of this, which is the controlled output, temporarily, and just feed the motor directly using some relays to feed the 120 volts into the Murgetroid motor for a short period of time just to get it spinning, and then I'd switch back into the output of this motor speed controller. Well, that certainly did work, and I was able to get the Murgetroid started, but the problem was that because I was switching from a relatively low voltage to a high voltage initially to get it to spin, that caused a serious glitch in the on the motor. It caused a big spike emitting radio waves that basically disconnected the Bluetooth that I'd used to connect to my microprocessor that I added for my new GUI that I just demonstrated. And so I would lose control of the graphical user interface, and the Murgetroid oftentimes would go off and do strange things and not behave at all normal. So I needed to do something, and my first approach was, well, let me back up a second. When I first built this thing, I used a single box like this box here, and I had the microprocessor, which is like this one here, inside the box, and then I had a bunch of these relays to do different various things, and they were in the box as well, so it was all together in one nice little neat box. But because of this glitching that was occurring, I decided I'd take the microprocessor and put it in a little box of its own, which I did. And I separated the box of the relays and the microprocessor. I separated them physically, a little bit difference, and that definitely helped. It did help, but I was still experiencing random disconnects and things that I didn't understand at all. So rather than switching in and out of switching in the output of the controller like I just described, what I chose to do is go in and tap the switch, which is built into the controller, and allows me to go to full power, to variable speed power. So I just tapped that switch to do what I wanted it to do. And that worked as well, and it worked a little bit better, but I still was experiencing random crashes. And at that point, I also noticed that my motor speed controller stopped operating properly. And so I replaced it and did some more experiments and killed that second one as well. In fact, I went through 4 of these boxes before I finally gave up entirely and decided I needed a different motor speed controller. So I looked on the web and I got on Amazon and found this guy here, which is does exactly the same kind of thing. It doesn't have that nice switch on the front, but it does have the variable speed control, and I can put in AC here and get out the control voltage there. And this worked very well, and it allowed me to do something the other one did not, and that was to tap into this resistor. The resistor, this variable knob on this first controller, unfortunately the resistor, it's a variable resistor, the terminals to it were not at all accessible. If you open this box up, I just could not get at that speed control. But with this guy, I could, which means that I could tap into the resistor, variable speed resistor, and tap into a new value. So what I would do is use relay and switch in a different resistor value and temporarily effectively boost the speed of the motor. And that worked, and it did it very nicely, and it did it, if I didn't boost it too hard, I could get just the right amount to get the Murgetroid moving and not create a sufficiently large glitch that would disconnect my Bluetooth, and all seemed happy for a little while until I noticed that the speed of the Murgetroid varied, the rotational speed, which I could now monitor with my new GUI. I noticed that it was varying as much as 100 RPM, plus and minus. I mean, it was not a plus and minus, but like plus 50, minus 50 type of thing. And that was just unacceptable. So what I needed to do at that point was design a motor speed control. And in order to do that, I basically added 4 relays to allow me to adjust the speed of the motor by tapping in different resistor values to this variable resistor. And I showed you I have them binarily weighted, and as such it gives me 16 motor speed positions. And that allows me to control the speed of the motor to an accuracy of about 30 RPM or so, plus or minus 15 or so. And it works extremely well, and doesn't experience any of the glitching that I've seen before. I still had some issues that I had to resolve from a software perspective that did indeed cause some crashing. If anybody's really interested, you definitely do not want to change a volatile variable. If you do that, you'll get a core dump. So don't change a volatile variable in your main program. I forgot to mention to you that along the way, as I was experiencing these glitches and motor speed variations, I decided to do an experiment. And I went onto the web and I purchased a DC motor. What I had been using is an AC motor, fan motor, or something equivalent to that. But I got this DC motor, and it operates at around 550 RPM. And I connected up a motor speed controller to it here and a microprocessor. And I did an experiment where I used this DC motor to drive the Murgetroid. And the reason I was trying to do this was that, one, this thing operates at a very low voltage. This is a 12 volt motor, and the motor speed control is extremely fine, gives me much more than 4 bits, 16 positions. I can go from 0 to full speed with this thing in very fine increments using just a simple knob. So I tried this out, and it actually worked extremely well, did everything I thought it would. But it had one serious problem, which I'll demonstrate for you in a minute here. But it is extremely noisy, and it was so noisy I simply could not live with it. So I abandoned the DC motor, went back to my AC motor and did all the work necessary to get that working, which is basically where we are at today. Okay, this is just a very short demo to show you the noise generated by the DC motor that I showed previously. So stay tuned, you'll see what happened there. So this is using a DC motor. I wanted to try it to see if it would work, and it certainly does work, but it's very, very noisy and it's going to disqualify it. But you can hear that, you can see that it is working, but too noisy. And I hope I didn't bore you all with that long video, but that is the situation. And right now I don't think there's much else I can do to the Murgetroid. In its present configuration, I am working on a new design, which is configured differently. I'm not going to talk about that in the moment, but there's still work going on. In any case, thanks for watching.